Well, welcome to section 2.2, linear equations. This is a real key, although kind of straightforward, section that deals with being able to understand lines and what they look like and how they behave and how to find the equations. And you're going to find that there's a ton of stuff in science and in a lot of the upper level math that we do where you need to be able to find equations of lines and understand what makes a line versus not a line. So these two lists here, linear versus nonlinear equations, the nonlinear are exactly that, some kind of a curve or shape that's not a line. The other ones, though, are lines. And so I want to talk specifically about what makes it a line, what makes it not a line. Linear equation has no operations other than addition, subtraction, division, and multiplication of a variable by a constant. So you're doing the multiplication by a constant, not with the variable. Over here, you'll see that this has 1 divided by x. What makes that not linear is that the division is not by a constant, it's by a variable. Notice on this one over here, all of the multiplication that takes place is with constants. So 6 times s, negative 3 times t, 5 and negative 3 again here. So all of those are linear. This is not linear because of the square root. This is not linear because of the multiplication of two variables together. And this one's not linear because of the squaring. So one of the things I want you to do is to be able to find some examples out in the real world of linear equations and be able to talk about them, why something is linear, what do you understand about that linear relationship. So here's the real simple example of what I'm kind of thing I'm looking for. So a while back there was this submarine that sank. I'm not sure what happened to it. You can go research that. But they have an equation here that defines the pressure at a certain depth, d. So they're telling you that d represents the depth of the water. And you can research why this 2117 is there and what the 62.5 is about. Those are very specific numbers, not just random made up ones. But the question is to find the pressure of on the ship at a certain depth. Now, if you're the captain of that ship and you're sinking, you need to know that, and being able to figure out that number obviously quickly is an important aspect. So as it turns out, all they do, it's real simple, right? You're just going to take the value of d that they give you, the depth of 350, replace the d with 350. Do the multiplication. They do a rounding off thing. Usually I don't want you to round off. If I do, I'll usually say in the directions round to the nearest whatever. But that's all that's going on. This is a linear relationship. So as the depth increases, the pressure is going to linearly increase as well. So another aspect of linear equations that's really important is being able to find the x and the y intercepts. So I want to back up a little bit. Let's just talk about some generic line here. So make up something about what are the coordinates of these 2 points. Take a second and just randomly make up something. Whatever it is you made up, here was the key thing. For this one, the y value is 0. And for this point, the x value would have been 0. And so to find the x and y intercepts, it's dependent upon setting x or y equal to 0. So if I wanted to find the x-intercept, I would simply set y equal to 0 on this equation. And now, by the way, this is a linear equation, right? Just multiplication. There's a 1 there. So only multiplication by constants, so that's what makes it linear. So when I set y equal to 0, this, of course, goes away, and I just get negative 2x minus 4. I added the 4 to the other side, and then divide by negative 2. So plot that point. The x-coordinate is negative 2. The y-coordinate, y-intercept, well, you're going to set the x-coordinate equal to 0. To do that, when x goes to 0, that goes away, and just y minus 4, add 4, and you get y equals 4. And then graph it, we just connect the dots, right? Pretty simple. So connect the dots, looks like that. Now, by the way, you could have taken this equation if I wanted to graph it. I could have put it into slope-intercept form. And the slope-intercept, that y equals mx plus b, look what happens when you get there. And sure enough, remember this guy down here is the y-intercept. And sure enough, the y-intercept is up here at 4. And the slope, remember here's the m, that's 2. So if I were to start at this point and go up 2 and over 1, up 2 and over 1, I'm plotting that line. So you could have used the slope and the slope-intercept form to find that equation and graph it as well. Where we started with that equation is something called standard form, although it wasn't quite in standard form. I'll talk about that in a second. See if you remember what standard form looks like. You would have discussed that back in Algebra 1 sometime. So standard form looks like this. ax plus by plus c equals 0. We don't use that a whole lot, but we end up starting often in that form and ending up in the slope-intercept form. Well, in this form, a couple of things. One of the things is the a value out here, it's always positive. So when they write it in standard form, they always have this first term as positive or non-negative. It could be 0. There may not be an x term. The a, b, and c are always integers. They never use any fractions or decimals to write it in standard form. So how does that work? So if I gave you this equation, notice that's in slope-intercept, y equals mx plus b. So if I want to put this in standard form, well, I'm going to get rid of the fraction first by multiplying both sides. Where did I do that? Oh, right here. I'm going to multiply both sides. Sorry, I didn't mean to put that line there. I'm going to multiply both sides by 3. So when I multiply over here by 3, and I multiply there by 3, and of course I'm choosing 3 because that's the common denominator. When I distribute, 3's cancel, I get 2. Distribute, I get 12. And over here, just 3y. And then I'm going to bring everything over onto the same side. But when I did that, I ended up with a negative for the a. And so last step I'm going to do there is to multiply through by -1. And everybody's sign changes. The 2x becomes positive, the 3 becomes negative, the 12 becomes negative, and that's now in standard form. So here's a couple of examples that are out of the book. You can kind of pause this and pull some of those out and try those yourself. Let me do a couple of them for you. What makes this guy linear is that all of the variables are simply being multiplied by a number, in this case just 1. What makes this not linear is that I'm dividing by a variable right there. This would be okay, but it's that 1 over x or 1 divided by x. Here's some problems that have to do with standard form and x and y intercept, being able to find those and graph those. So play around with a few of these, try those, and see if that helps you out. We'll definitely need to be able to have this concept figured out. So hopefully this helps.